Hello students, welcome to Science Workshop 2023, a joint initiative taken by Evershine Coaching Center, Tannery Road, Bangalore and Ashwini Public Group of Institutions, Laggere, Bangalore for the progress and good results in the upcoming SSLC board exam, Karnataka board. I am Lakshmi, teaching since 2018. Today in this session, we will be discussing the various parameters. Are you finding it difficult? What should we read in the last minute? How do I pass? How do I score? What to read and what not to read? Very important questions. I'm weak in science and maths. If I study papers from the previous year, will that be enough to pass the exam? Okay, today in this class, we will discuss some important topics related to acid, bases and salts. Acid, bases and salts chapter, and then we will discuss some important topics of related to metals and non-metals, and some important topics related to carbon and its compounds. Carbon and its compounds. Okay, these three topics, these three lessons we will study, and firstly we will move on to acids, bases and salts. Acid, bases and salts. In this chapter, which are the important topics we will study, what important questions we will get. Okay, so can you tell me what is acid? What is acid? Yes, acid is a substance. Acid is a, please take down. Acid is a substance which dissociates to give H plus ions. Acid is a substance which dissociates to gives H plus ions when diluted. Acid is a substance which dissociates to give H plus ions when diluted. So in acid, there are two types of acid. Which are there? So in acid, there are two types. One is natural acid and synthetic acid. Natural acid and synthetic acid. Okay, what do you mean by natural acid? Natural acids are nothing but acids that are obtained naturally. Acids that are obtained naturally are called natural acids. Acids that are obtained naturally are called natural acids. What do you mean by synthetic acids? Yes, acids that are prepared in laboratory. Acids that are prepared in laboratory are called synthetic acids. Got it? So acid is a substance which gives H plus ion. So what acid in common contains? H plus ion. So you can take any acids. In those acids, what commonly we can see is what commonly it contains. What ions it contains in common? Yes, in common it contains H plus ions. Okay, so give examples. Let us see examples for natural acids. Give examples for natural acids. Tell me some examples for natural acids. Give some examples of natural acids. Give example for natural acids. Okay. Okay, take down. I'll tell the source and acid present in that source. For example, apple. Apple contain what acid? Apple contains malic acid. Tell, for example, lemon. Lemon contains citric acid. And another source is milk. What does milk contain? Milk contains lactic acid. Okay, these things we get naturally, and we can see some natural acids in this. Apple, malic acid, lemon, citric acid. What does tomato contain? Tomato contains oxalic acid. What does tamarind consist? Tamarind consists of tartaric acid. Tamarind consists of tartaric acid. Then what does ant bite releases? Ant bite releases methanoic acid. Ant bite releases methanoic acid. Bee sting. Bee sting consists of methanoic acid. Okay, since we know this, all materials we get naturally, and the acid present in this is natural acid. Got it, all of you? So these are the natural acids. And one more, nettle leaves. What does nettle leaf consist of? Yes, nettle leaf consists of methanoic acids. Since these we get naturally, these are called natural acids. Getting? And what is the taste of lemon, tomato, tamarind? Sour. So from sour taste. From this, what we can understand, acids are sour in taste. Acids are what taste? Sour in taste. So you can see any apple, lemon, milk, tomato, all these will be sour in taste. So from this we can understand some acids are always what taste? Sour in taste. And what does acids contain in common? H plus ions. Okay. Next we will study some synthetic acids. So what do you mean by synthetic acid or artificial acid? Yeah, synthetic acid or artificial acids are nothing but, what do you mean by synthetic? Synthetic means synthesis means what? Yeah, so these are prepared in laboratory. So synthetic acids are those acids which are prepared in laboratory. So the acids which are prepared in laboratory are called synthetic acids. So can you give some examples for synthetic acid? Hydrochloric acid. So HCl is hydrochloric acid. HCl is having the formula H. What is the formula of hydrochloric acid? HCl. So in this you can see it is having H plus and Cl minus. When you put this acid in water, it dissociates into H plus and Cl minus. Coming to H2SO4. What is H2SO4 called? Sulfuric acid. In sulfuric acid there is H plus and SO4 minus. SO4 minus, 2 minus. Coming to HNO3. What is HNO3 called? Nitric acid. In this also you can see H plus and NO3 minus. So when you split this into anion and cation, you can commonly see one in common. What is that? H plus. So from this we can understand acids in common contains H plus ions. Acids in common contains H plus ions. So when we put this acids in the water, it splits into ions. What ions? One is positive ion, another one will be negative ion. Got it? What acids have in common then? H plus ions. So what are the two types of acids now? natural acids and synthetic acids. Natural acids means the acids we get naturally. There are several sources which gives natural acids, and there are some acids which are not we do not get naturally, but it has to be synthesized in laboratory. So name some important acids which are synthesized in laboratory. HCl, H2SO4 and HNO3. H2SO4 and HNO3. Okay. Okay. So then next topic is what is a strong acid and weak acid. What do you mean by strong acid and weak acid? What is strong acid and weak acid? What is strong acid and what is weak acid? Strong acid means which completely splits into ions when it is diluted. So what do you mean by weak acid? Weak acids are those acids which do not completely dissociate into ions. Only partial dissociation takes place. Partial dissociation of ions is those acids are called as weak acids. So you understood what is strong acid and weak acids? What do you mean by strong acids? Acids which completely dissociates into ions when it is diluted. What do you mean by weak acids? Acids which partially dissociates into ions are called as weak acids. Okay, so then we have studied what are the important topics now. What and all we have studied now? We have studied acid. In acid there are how many types? Two types. Which are they? Natural acids and synthetic acids. Natural acids and synthetic acids. So natural acids I have told so many examples. Synthetic acid, give example, HCl, H2SO4 and HNO3. So in this synthetic acids are also there are two types. Which are they? Which are they? Strong acids and weak acids. What do you mean by strong acid? Acids which completely splits into ions. So when we dilute those acids, if completely dissociates, then it is strong acids. Weak acid means it will dissociate partially. Give example for weak acid. CH3COOH is a weak acid. Why CH3COOH is a weak acid? Because it partially dissociates into ions. Okay. So then we have studied some sources of acids, right? Then we will study what do acid conducts electricity. Do acids conduct electricity? Do acid conduct electricity? They'll ask you in the exam, why do acid conduct electricity in aqueous solution? Why do acid conducts electricity in aqueous solution? Why does it conduct electricity? Because acid when put in water, it completely dissociates into ions. The movement of these ions helps in what? Helps in conduction of electricity. Helps in conduction of electricity. So they'll every time ask this question, why acids conducts electricity in aqueous solution? Why acid conducts electricity in aqueous solution? Because when acid is diluted in water, it splits into ions. The movement of these ions helps in conduction of electricity. And also they will ask you to draw diagram showing acid conducts electricity in aqueous solution. So for that we need to draw a beaker. We need to draw a beaker. Inside the beaker, what we need to take? Acid. Which acid? We can take any acids. Dilute hydrochloric acids. The thing is, you need to take dilute acid, because when you take dilute acids, it will completely splits into ions. Then you keep a rubber cork and insert to iron nails. Connect the iron nails to battery, switch, bulb. Okay, what is this diagram? This diagram is acid conducts electricity. Acid conducts electricity in aqueous solution. Okay, this is also important topic for exam, and this will be carrying 2 marks. Acid conducts electricity in aqueous solution, and then you need to label. So this is beaker, rubber cork, iron nail, switch battery, switch, and this is bulb. Okay, so this is a diagram showing acid conducts electricity, and in this also they'll ask why acid conducts electricity, and draw a neat diagram for showing acid conducts electricity in aqueous solution. Directly you can't pass electricity for direct acids, you can't pass. We can pass the electricity for dilute solution of acid. For dilute solution of acid. Okay. So then we will study about they can ask question in indicators. Indicators. So what do you mean by indicator? What do you mean by indicator? What is indicator? Indicator is a substance which will identify. Yeah, indicator is a substance which will identify acid or a base. Identify acid or a base. Okay, in indicator, how many types of indicators are there? 3 types. Which are there? Natural indicator, synthetic indicator, olfactory indicator. Okay, these are the 3 types of indicator. So indicator means it indicates whether a substance given is acid or a base. So give example for natural indicator. Natural indicator is litmus paper or turmeric powder. So turmeric and litmus is a natural indicator. Give example for synthetic indicator. Phenolphthalein indicator. Phenolphthalein indicator. Methyl orange indicator. Methyl orange indicator. Give example for olfactory indicator. Cucumber, clove, onion. Okay. So in this important one is olfactory indicator. And every time in exams I will ask what is olfactory indicator. What do you mean by olfactory indicator? Indicator which changes its smell in base. Indicator which changes its smell in base. Getting? Indicator which changes its smell in base are called as olfactory indicator. Natural indicator means the indicator which we get naturally. Synthetic indicator means the indicator which are prepared in laboratory are called as synthetic indicator. Okay, So then we should know what the color change it will give when we keep that indicators in acid as well as base. Coming to litmus, what litmus shows its color in acid and base? In litmus paper there are two types. Which are there? Red litmus paper and blue litmus paper. Red litmus and blue litmus. So what happens when we keep red litmus in acid? Red litmus in acid. In acid it will show red only. What happens when you keep red litmus in base? Red litmus changes into blue. When you keep red litmus paper in base, it will change into blue. Okay, what happens to blue litmus paper? Blue litmus paper in acid shows what color? It will show red color. Blue litmus paper in base. In base it will show blue itself. Okay, so by using this litmus paper, what we can identify? We can identify acid or a base. Got it? Okay, then you are asked with a question. You have given 3 test tubes. You have given with 3 test tubes. One test tube consists of water. One test tube consists of acid. Another test tube consists of base. How will you identify using litmus paper? How will you identify acid, base and water using litmus paper? They'll not tell you what is given in what test tube. You need to identify. How will you identify? Yeah, you can keep the litmus paper in water. Do it change? It show any color change? No, it will show no color change. If it is showing there is no color change, what does it mean? Yeah, it means that it is neither acid nor a base. So when you keep red litmus paper in acid, sorry, blue litmus paper you should take and keep it in acid. It will change into red. If it is changing from blue to red, what does that solution? It consists of acid. And if you take what litmus paper in base? If you take red litmus paper in base, it will change into blue color. So by this we can identify acid, base and water. Okay, then ask you this question. So you have given with a test tube A, B, C. It consists of water, acid and base. They will not tell which is acid, which is base. You need to identify using litmus. How can you identify using litmus? Take the red litmus paper and dip in acid. It will change into blue litmus paper in acid. It will change into red. Red litmus paper in base. It will change into blue. In water, if you dip any litmus paper, it will not show any color change. So by this experiment we can identify acid, base and water. Okay, so next, which is another indicator? What is other indicators we can use for you identifying acid, base? Phenolphthalein indicator. What is another indicator? Phenolphthalein indicator. What is the color of phenolphthalein in acid? In acid it will show colorless. In base it will show pink. Okay, so using phenolphthalein also you can identify acid and base. Put some in phenolphthalein in acid it will show colorless. Phenolphthalein in base it will show pink color. So by using phenolphthalein also you can identify acid and base. What about methyl orange? What about methyl orange? Methyl orange in acid. Methyl orange in acid. Red. Methyl orange in base, yellow. Got it? All of you? Yes. Next, which is another indicator? Olfactory indicator. Do olfactory indicator show any color change? Then what it will show? Yes, olfactory indicator changes its smell in base. So this is very important question. What is olfactory indicator? Indicator which changes its smell in base are called olfactory indicator. Give example for olfactory indicator. Onion, clove, cucumber. These are the examples for olfactory indicator. So this is also important. Next, instead of using so many indicators, we can use one universal indicator. Which is that? Yes. So universal. Instead of using turmeric, phenolphthalein and many indicators, there is a one indicator that is called universal indicator. So which is a universal indicator means pH scale. Okay, pH scale ranges from 0 to 14 and below 7 in the scale indicates acid, above 7 in the scale indicates base. So if you keep this indicator in milk, since milk has lactic acid, it should show below 7. So water, it should show neutral. So water, if you keep this pH scale in water, it will show the value 7. In magnesium hydroxide is an antacid. If you keep this pH scale in a magnesium hydroxide, it has to show basic value, that is above 7. If you keep this pH scale in sodium hydroxide, since sodium hydroxide is a very strong base, it will show the value 14. So by using this pH scale, we can identify acid or a base. So what do you mean by pH? pH is a measure of hydrogen ion concentration in the solution. So pH scale, if below 7 it is showing, then hydrogen ion increases and then it will show acidic value. If the pH is showing above 7 and above, then what ions increases, they'll ask in the exam. You need to tell it's OH minus ions increases. And then the last very important question, what is neutralization reaction?
Formulas of salts, and these are the very important formulas: washing soda, Na2CO3, sodium carbonate. My dear students, you need to remember that the other name of these all salts and also their molecular formula, and these questions are very important for your examination point of view. Again I am repeating: washing soda, Na2CO3, sodium carbonate; baking soda, NaHCO3, sodium bicarbonate; then bleaching powder, calcium oxychloride, CaOCl2, calcium oxychloride; plaster of Paris, CaSO4, half water, 1/2 H2O, that is also called as calcium sulfate hemihydrate. Do remember, calcium sulfate hemihydrate. Next, gypsum, CaSO4, twice water. Twice of water means 2 H2O. CaSO4, 2 H2O. Calcium sulfate. Okay. So, my dear students, you need to remember these all very important salts: calcium sulfate dihydrate, calcium sulfate hemihydrate. This is 1/2 hemihydrate, 2 times dihydrate. Next, very important question for 1 mark. You may expect this question, and this question has repeated most number of times in the exam for 1 mark. Magnesium hydroxide. It is a good antacid and it is called as milk of magnesia. And remember students, this is an antacid. It is used to reduce the acidity of the stomach. Okay. So dash is used to reduce the acidity of the stomach. You need to remember, that is magnesium hydroxide. It is usually called as milk of magnesia. It is a good antacid which is going to remove or reduce the acidity from the stomach. And next next topic is neutralization reaction, and already we have discussed what is neutralization reaction in our previous sections. And remember, here also few topics are there which are going to help us in neutralization reaction, such as tooth decay. Now even in tooth decay we can see there is a neutralization reaction. Usually how the tooth decay takes place? When the pH decreases below 5.5, then tooth decay takes place. Remember this very important question. Again I am repeating, very important question. When does the tooth decay takes place? The tooth decay takes place when the pH decreases below 5.5. When the pH value decreases below 5.5, then tooth decay takes place, so that the acid formation takes place due to the bacteria. Okay, when the pH is going down, it's nothing but due to bacteria, so acid formation takes place. So to remove this acid we need to add a base. Okay, by applying a base we can make the reaction neutral, so that the tooth decay will get prevented. How can you prevent tooth decay? By using the base. Very good. What is the best example for base? Your toothpaste. We are applying the toothpaste, that is a base. It is a best reducing agent. Okay, so that what happens when acid and base reacts, it forms salt and water. So paste is nothing but by adding the base we can get rid from the tooth decay. Next, digestive system. Even in digestive system also we can find neutralization reaction. As you know, due to the acidity in the stomach, acid formation takes place. So by adding the base, what is the base here? Magnesium hydroxide, that is milk of magnesia, that is nothing but antacid. So here antacid is a base. By adding the base, okay, how the stomach forms acidity? Due to formation of hydrochloric acid, HCl. Due to the formation of HCl, okay, when the HCl rises, okay, the acidity increases. Due to the acidity increases, we are using antacid, that is nothing but a base. Okay, so the reaction get neutral. So salt and water formation takes place, so the acidity get decreases. So how can you get rid from tooth decay? How can you prevent acidity? Such type of questions usually commonly you can see in your exam question paper, and this is the common questions as we can see even in our day to day life. Okay, and very most important question. This is the very favorite question for the examiner usually, as we can see here. Yes, this is the topic. Why farmer use base to the soil in his agricultural field? Okay, can you tell me the answer for this? Why farmer is using the base in his agricultural field? Okay, very simple. He is adding the base in the agricultural field. Usually as we can see, soil when it get acidic in nature, when soil becomes acidic in nature, so crops cannot be grown or we cannot yield the crops properly. When soil becomes acidic, remember, when soil becomes acidic, the crops cannot be grown or the yield doesn't take place in a proper manner. So the farmer use base. So here if the question asks for you in the exam, why farmer add base to the soil? Okay, so let they ask in any of the form, the answer should be same thing, to neutralize. Okay, he is adding the base to neutralize excess acid in the soil. To neutralize the excess acid in the soil, farmers add base and can obtain high yield crops. So he is using base to remove the excess acidic particles. Okay, next topic. Now here we can see the uses of these salts, very important. These uses of these salts are very important, such as bleaching powder, washing soda and baking soda. Bleaching powder, calcium oxychloride, CaOCl2, washing soda, Na2CO3, sodium carbonate, baking soda, NaHCO3, sodium hydrogen carbonate. Now these questions are very important, again I am repeating. Okay, the uses of bleaching powder are they are used to bleach, okay, and also they are going to use to kill the germs, and they are the good oxidizing agent in chemical industries. Very important question, children, don't forget this. And this is the most repeated topic which has been asked in the exam, even in multiple choice question. Which is the best oxidizing agent in which is used in chemical industry? That is bleaching powder. Bleaching powder is the best oxidizing agent which is used in chemical industry. Next, washing soda. It is used in the manufacturing of borax, glass, paper, and also it is used for domestic purposes. And next, it is also used to softening the hard water. What is softening means? It is converting hard water into soft water. We are going to use washing soda, okay. And here this is very important because this term is already appeared in the exam. Dash is used, okay, in softening the hard water, that is washing soda. Washing soda is used to softening the hard water and also in the manufacturing of borax. So this term is already appeared in the question paper. Don't forget borax name and softening the hard water. And next is baking soda. It is used in the it is used as a baking powder, okay, and also it is used as an antacid, and also it is used in the soda acid fire extinguisher, okay. And here remember, baking powder is nothing but baking soda plus tartaric acid. The combination of this both is baking powder, okay. And here this term is very important, that is soda acid fire extinguisher. We are using baking soda.
Okay, so this is important. So next we'll move on to how to dilute the acid. How to dilute acid? How will you dilute acid? How we should dilute acid? How to dilute acid? How to dilute acid? Tell me. So we should mix. We should mix. So in a beaker we should take water and we should add acids. How we should add? Dropwise. We should add dropwise acid to water. This is how we need to dilute. What happens if you put acid to acid directly water? If you mix, what happens? Yeah, it will splash. It will splash out. It will cause some accidental fire. It will react more vigorously. So this is also another important question they'll ask. While diluting, what important question they'll ask? While diluting, it is necessary to add what? Dropwise acid to water, not water to acid. Why? Why? Because if we add water directly to acid, it will react vigorously and splashes out. In order to avoid this, we should add acid dropwise to water, not water to acid. Okay, this is also important question. Then what is brine solution? What is brine solution? Yeah, brine solution. Brine solution is a mixture of NaCl and water. This is also important. What is brine? Brine is a mixture of sodium chloride and water. Okay, so then what is chlor-alkali process? What is chlor-alkali process? What is chlor-alkali process? It is a method of preparing NaOH by using brine solution. Very important question. What is chlor-alkali process And what is brine solution? What is brine solution? Brine solution is a mixture of, brine solution is a mixture of sodium chloride and water. Brine solution is a mixture of sodium chloride and water. Nothing, just salt plus water. Salt and water gives brine solution. Then what is chlor-alkali process? It is a method of preparing sodium hydroxide. What is sodium hydroxide? Sodium hydroxide is a base. So method of preparing NaOH is called chlor-alkali process. Getting? Can you answer what is brine solution and chlor-alkali process? Yeah, what is brine solution? What is chlor-alkali process? Okay. So then they don't ask diagram, but you should know how it is prepared. Okay. So then we will study what is chlor-alkali process. So what do you mean by chlor-alkali process? Chlor-alkali process is a method of preparing NaOH. Chlor-alkali process is a method of preparing NaOH. So how to prepare NaOH? For that one diagram is there. You need to write the diagram. So in a big tank, what should be taken? What should be taken in a big tank is brine solution. So what do you mean by brine solution? Brine solution is a mixture of, what is brine? Brine is a mixture of NaCl and water. So brine solution should be taken in a big tank. For this tank, we need to insert two what? What rods it is? It is a graphite rods. Okay, so we should keep two graphite rods. So why we should use graphite rod in this? Because graphite rod is a very good conductor of electricity. So in a brine solution, we should use graphite rods. So this blue color what I am drawing is brine solution. So brine solution is a mixture of salt and water, NaCl and water. For this brine solution, we should keep two graphite rods, and then this graphite rods should be connected with battery. So one should be connected to positive, another should be connected to negative. So the positive plate is called anode, the negative plate is called cathode. Okay, on passing the electricity to brine solution, what happens? What happens on passing the electricity to brine solution? NaCl splits as Na plus and Cl minus. H2O splits as H plus and Cl minus. So what happens now? Sorry, H2O splits as H2O splits as H2O splits as H plus and OH minus. And this Na plus and OH minus combines to form NaOH. So that can be taken out by another outlet. And this HCl will be liberated at the anode. Because Cl is negative, so it will be liberated at the anode plate, and hydrogen gas will be liberated at the cathode plate. So here three materials are also useful. NaOH we can use for preparing soap, And this hydrogen gas can be used as a fuel. And this chlorine can be used for preparing bleaching powder. Okay, so this is chlor-alkali process. Chlor-alkali process, in this process, what importantly we are preparing is, we are preparing NaOH. So three useful materials we will get from this process. One is hydrogen gas, one is chlorine gas, another one is NaOH. So NaOH we can use it for preparing soaps, detergents, paper, and hydrogen gas can be used for fuels. It's used as a fuel. It can be used as ammonia for fertilizer, and this chlorine can be used for, can be used as CFCs, and then it can be used for PVC pipes, and it can be used for preparing bleaching powder. So chlor-alkali process is a method of preparing NaOH. Any doubt here? Okay, so next we will move on to preparation. Next we will move on to preparation. How to prepare? How to prepare bleaching powder. This is also important topic. How to prepare bleaching powder? How to prepare bleaching powder? We can prepare bleaching powder by passing the chlorine gas to slaked lime. So here CaOH twice is slaked lime and Cl2 is chlorine gas. When we pass chlorine gas to slaked lime, we get bleaching powder and we get water. So this is how we can prepare bleaching powder. So bleaching powder can be prepared by passing chlorine gas to slaked lime. CaOH twice is slaked lime. By passing chlorine gas to slaked lime, we get bleaching powder. So this is how we can prepare bleaching powder. Next, how to prepare gypsum. How to prepare gypsum. So gypsum can be prepared by adding water to POP. By adding water to POP, we can prepare gypsum. So POP is CaSO4 half H2O. So water 1.5 H2O gives gypsum CaSO4 dot 2 H2O. So by adding water to by adding water to POP, we obtain gypsum. So in reverse, if we take gypsum and heated it to 373 Kelvin, we get POP. So this is also another important question for exam. How to obtain POP? How to obtain POP? POP can be, how to obtain POP? POP can be obtained by heating gypsum to 373 Kelvin. So POP can be obtained by heating gypsum to 373 Kelvin. This is also important topic. How to prepare gypsum and how to prepare POP. So POP can be obtained by heating gypsum to 373 K. Another important question here they'll ask you is, why POP should be stored in moisture proof container? Why POP should be stored in moisture proof container? This is also another important question. Why POP should be stored in moisture proof container? Why POP should be kept in moisture proof container? Because if we keep them outside, If it is kept outside, if POP is kept outside, it will react with moisture, or it will absorb moisture, react with moisture or absorb moisture, and becomes hard mass, and becomes hard. That cannot be useful for anything. So what we have to do, we have to always store them in moisture proof container. In order to prevent it to become very hard, we should store them in a moisture proof container. So this is also another important topic, why POP should be stored in moisture proof container.
The one who is not interested, please go down, sit in the class.
Okay, so we have covered important topics in acids. In acids, which are the important topic you should know is about indicator you should study. In indicator, you should study about olfactory indicator. Olfactory indicator is an indicator which changes its smell in acid and base. And then you should know about pH. pH is a measure of H plus ion concentration. And then you should know about pH scale. pH scale ranges from 0 to 14. Below 7, if it is showing H plus ions increases. Above 7, it is showing OH minus ions increases. So you should know about pH scale. And then you should know important topic, that is neutralization reaction. So neutralization reaction means acid and base reacts to form salt and water. So this is also important topic. So these are all already I have explained. Once you go through this, you will know acid and base reacts to form salt and water. Another important question is, why does tooth decay? This also you need to study for exam. So the food stuck in mouth is degraded by bacteria. Bacteria releases acid. So because of the acid release, the pH of the mouth decreases below 5.5, hence tooth decay. And then why farmer add base to the soil is also another important question. Farmer add base to the soil to neutralize excess acid in the soil. And why milkman add base to milk also, they'll ask. Milkman add base to milk to increase its shelf life. That means to reduce the time of setting into curd. And then what is antacid is also another important question they'll ask in exam. Antacid example they'll ask. Antacid is MgOH twice. It is milk of magnesia. It's a very good antacid. It reduces the acidity in the stomach. So these are all the important questions I'm writing down. So these are all based on neutralization reaction. So they'll ask this question, very important. Why does tooth decay? Why farmer add base to soil? Why milkman add base to milk? Why? What is an antacid? Give example for antacid. Or MgOH twice is what they'll ask in. Choose the correct answer. MgOH twice is a very good antacid. And some more important questions they can ask is how to dilute. How to dilute an acid. Why it is necessary to it is necessary to add acid dropwise to water. This is also they'll ask. This and all I have covered in this video. You go through that, you will know the answer. And then they'll ask you what is brine solution. They'll ask what is chlor-alkali process. Chlor-alkali process is a method of preparing NaOH. Brine solution means it is a mixture of NaCl and water. And then they may ask diagram of chlor-alkali process diagram. So here in this chapter you get three diagrams, very important diagrams. One is acid conducts electricity. One is acid conducts electricity in the aqueous solution. The other one is acid reacts with metal and releases hydrogen gas. And another one is chlor-alkali process of preparation of chlor-alkali process of preparation of NaOH. These three important diagrams. In that, very important one is the first one and the second one. First diagram is for 2 marks and the second diagram is 3 marks. Chlor-alkali process is an option. They may ask or they may not. But acid plus metal gives hydrogen gas is very important diagram. And then you should know the uses of salts like baking soda, washing soda, bleaching powder, POP, gypsum, and POP is used. POP uses also I have told, and then uses and their formulas also you should note down. Bleaching powder formula, washing soda formula, and these are all the important topics. So 3 to 4 marks you will get related to this and one diagram I didn't explain that I am explaining here. Take a test tube. Inside the test tube we should take some zinc granules and dilute H2SO4 and close the test tube with a rubber cork. Inside a insert a insert a glass tube into it. This is called delivery tube, and this delivery tube should be uh, passed or kept inside the beaker containing the soap solution. So this is soap solution, and this is a test tube, and fix this test tube to a stand. Inside the test tube we should take some zinc granules and dilute H2SO4. So zinc and dilute H2SO4 reacts to produce hydrogen gas. So this hydrogen gas should be passed through soap solution. So what gas we are getting is hydrogen gas. When we pass this hydrogen gas to soap solution, it starts giving bubbles. So this bubbles should be burned with candle light. It burns with pop sound. So what does this indicates? Why this bubbles are burning with pop sound? Because it is an hydrogen gas. Hydrogen always burns. It burns with a pop sound. So by this experiment we can identify whenever a metal reacts with sulfuric acid or any acid, it liberates hydrogen gas. So metal reacts with acid and produces hydrogen gas. This also, to choose the correct answer, they'll ask you what does metal produces when it is put in acid. So metal reacts with acid and always it produces hydrogen gas. So this is also an important. So this diagram is for 3 marks and what gas it releases is for 1 mark. Okay, metal reacts with acid and produces hydrogen gas. Metal react with acid and produces hydrogen gas. So zinc plus H2SO4 reacts to give H2. So here we should write the reaction. Zinc means Zn. Zinc granule we have taken. And then we have taken sulfuric acid H2SO4. Zn plus H2SO4 gives ZnSO4 plus H2 gas. Okay, ZnSO4 is zinc sulfate. The zinc sulfate will be settled down in the test tube, but hydrogen gas will be liberated. That hydrogen gas should be passed to soap solution and then it will gives bubbles. This bubble should be burned with candle. It will burn with pop sound. So this is also an important diagram for 3 marks. So in this page what you can understand is metal react with acid and produces hydrogen gas. And this diagram also very important for exam. Okay, this is all important topic. And one more important question I told you, why POP should be stored in moisture proof container. Why it should be stored in moisture proof container? If it is kept outside, it will react with moisture and it will become very hard. that will become unuseful. That is why we should always store the POP in the moisture proof container. And then they may ask use of POP also. POP is used to fix the fractured bones in the right position. It is used to fix the fractured bone in right position. Is used to fix the fractured bone in right position. And also it is used to make some idols, statues, and decorative items. Decorative items. So these are all the uses of POP. Okay, so for exam you need to study uses of all sorts related to this lesson. Uses of all sorts. So this is all important topic related to acid, bases and salt. Okay, then next we will go to metals and non-metals. We'll go to the next chapter, metals and non-metals. Okay, in this chapter they'll ask you physical properties of metal. Physical properties of metals. So what are the physical properties of metals? They may ask. What you can write physical property of metal? Metals are malleable. Metals are malleable. Metals are ductile. Metals are sonorous. Metals are good conductor of electricity. Metals are good conductor of electricity. Metals are good conductor of, and metals are lustrous. Okay, so you should know what is malleable. What do you mean by malleable? Malleability means making the metal into, what is malleability? Making metal into thin, making metal into thin sheet is called malleability. What do you mean by ductility? What is ductility? So making metal into thin sheet is called malleability. What do you mean by ductility? Drawing metal into thin wires. Drawing metal into thin wire is called as ductility. This property of metal is called as ductility. Drawing metal into thin wire is called as ductility. So which is the most ductile metal means it is gold. And then what is sonorous? Sonorous means it can produce ringing sound. What do you mean by good conductor of electricity? That means any metal for that matter, it will pass current through it. What do you mean by lustrous? Lustrous means shiny. Metals are shiny. Shining, for the shining we use the word luster. But sonorous means it produces ringing sound. Okay, this is all the important topics. In this you will get what is malleability and what is ductility, or else directly they'll ask what are the physical properties of metals. What are the physical properties of metals? So physical properties of metals as well as non-metals they'll ask. For non-metals you should write reverse of this. Non-metals are non-malleable. Non-metals are non-malleable. Non-metals are non-ductile. Non-metals are non-sonorous. Non-metals are bad conductor of electricity and heat. Non-metals are non-lustrous. So these are all the properties of non-metals. So these are all the properties of metals. These are all the properties of metals, and these are all the properties of non-metals. in this topic related to properties, they'll ask which is a liquid metal. All metals are usually hard. Which is the liquid metal means what you have to write? Which is the liquid metal? Mercury. So usually metals will be all metals will be solid. All metals will be solid, but there is a one metal which is liquid. Which is that liquid metal? Which is the liquid metal? Mercury. This also they can ask for exam. Which is the liquid metal? Mercury. And usually all metals will be hard. We know this. Metals will be hard. But which is the metal which is very soft? They can ask. Which is the soft metal? Which is the soft metal? Sodium or potassium. Which is the soft metal? Which is the soft metal? Sodium or potassium. Usually metals will be hard, but which is the soft metal means we should know it is sodium, and potassium is the soft metal. And which is the best conductor of electricity, or which is the best conductor of heat and electricity? They may ask. Which is the best conductor of heat and electricity? It is best conductor of electricity is silver. Best conductor of or poor conductor of heat. Poor conductor of heat. Poor conductor of heat. Poor conductor of heat is mercury. So liquid metal is, which is the liquid metal? Mercury. Which is a soft metal? Which is a soft metal? Sodium. Which is the best conductor of electricity? Silver. Which is the poor conductor of heat? Mercury. And so this is all about properties and important topic related to properties. Which is the shiny non-metal? Which is the shiny non-metal? Which is the shiny non-metal? Iodine. So shiny non-metal is iodine. So like this some important topics will be asked. And what is malleability is also another important topic. What is ductility is also another important topic. So what is malleability? What is malleability? Metals are made into thin sheet is called malleability. What is ductility? Metals are made into thin wires is called ductility. So this is for 1 mark or 2 mark in exam. So this also they can ask as choose the correct answer in that, which is the liquid metal means mercury. And here they'll ask why sodium and potassium is always stored under kerosene. Why sodium and potassium is always stored under kerosene. So this is also important question that comes in exam. Why sodium or potassium will be stored under kerosene? What answer we need to write for this? Why sodium and potassium will be stored under kerosene? Because sodium is high reactive metal. Sodium is high reactive metal. It reacts with atmospheric oxygen. Reacts with atmospheric oxygen or moisture and catches fire. To prevent this, always sodium or potassium is stored under kerosene. So this is the answer. You need to write why sodium and potassium will be stored under kerosene. Sodium and potassium reacts vigorously with atmospheric oxygen and catches fire. To prevent this, they are always stored under kerosene. This is also an important question for the exam. Next we'll go to reactions of metals. First we'll see how metal react with oxygen. Metal react with oxygen and forms metal oxide. Metal reacts with oxygen and forms metal oxide. For example, copper. Copper reacts with oxygen and forms copper oxide. Copper reacts with oxygen and form copper oxide. Aluminium. Aluminium is a metal. Aluminium reacts with oxygen and forms aluminium oxide. Aluminium reacts with oxygen and forms aluminium oxide. So in general, metal reacts with oxygen and forms metal oxide. In general, metal react with oxygen and form metal oxide. So they can ask how copper react with oxygen. How what you will write? Copper reacts with oxygen and form copper oxide. They can ask how aluminium reacts with oxygen. You should write aluminium 4Al plus 3O2 gives Al2O3. Why we should write Al2 and why we should write O3 there? Because aluminium is having plus 3 valency, oxygen is having minus 2 valency. Cross multiply this. So we will get aluminium oxide as Al2O3. Why we should write CuO only? Because copper is having plus 2 valency, oxygen is having minus 2 valency, plus 2 minus 2 cancel and forms copper oxide. So for copper oxides we should write CuO. For aluminium oxide we should write Al2O3. So this is how metal react with oxygen. So here another important question they'll ask you is amphoteric oxides. Another important question they'll ask you here is amphoteric oxide. Very important for exam. Amphoteric oxide. So what are amphoteric oxides? Give example they'll ask. What are amphoteric oxide? Give example. Important question this is. Amphoteric oxide means there are some oxides like zinc oxide or sodium oxide or potassium oxide or aluminium oxide. These are all called amphoteric oxides. What happens? Why they are called amphoteric oxide? Because these some oxides like all these above oxides reacts with acid as well as base. Reacts with acid as well as base and forms salt and water. So important question in metals and non-metals is what are amphoteric oxides and give examples. So for amphoteric oxides, ZnO, zinc oxide, Na2O, sodium oxide, K2O, potassium oxide, Al2O3, aluminium oxide. These are all the important metal oxides. These metal oxides are called amphoteric oxides. Why these are called amphoteric oxides? Because this reacts with both acid as well as base, okay, to form salt and water. Any such oxides that reacts with both acids as well as base are called amphoteric oxides. See down, I have written the reaction. Al2O3, it's an aluminium oxide. It is reacting with hydrochloric acid to form salt and water, and also the same aluminium oxide Al2O3, it's reacting with base NaOH to form salt and water. So some oxides are there that react with both acids as well as base to form salt and water. Such oxides are called amphoteric oxides. So here examples are given. Then how metal reacts with water? So for sodium and potassium is a very high reactive metal. Sodium metal and potassium metal react with sodium metal and potassium metal react with water and forms respective hydroxides. NaOH, sodium hydroxide, KOH, potassium hydroxides, and liberates hydrogen gas. These hydrogen gas will catch fire because there is more evolution of heat. Because of more evolution of heat, the hydrogen gas catches fire, and this reaction is also called as exothermic reaction. Very important question. How does sodium and potassium reacts with water? Sodium and potassium reacts with water and forms sodium hydroxide and liberates hydrogen gas. Potassium reacts with water and forms potassium hydroxide and liberates hydrogen gas. And this hydrogen gas will catch the fire because of more heat. So another important question is how calcium reacts with water. How calcium reacts with water. Calcium reacts with Ca is calcium, H2O is water. Calcium reacts with water and forms calcium hydroxide, CaOH twice, and also liberates hydrogen gas. So here the hydrogen gas released will not catch fire. Why? Because during this reaction the heat liberated is not sufficient to catch the fire. This is also a very important question. Why does calcium reacts with water and forms calcium hydroxide and hydrogen gas? Calcium hydroxide and hydrogen gas. The hydrogen gas produced will not catch fire. Why? They'll ask. Will not catch fire. Why? They'll ask. What you need to write? The heat liberated during this reaction is not sufficient to catch fire for hydrogen.
Gold or silver are the least reactive metal, and this question is very important for your examination point of view. They can ask you among the following which is the least reactive metal, that is gold or silver. They are the least reactive metal. And next, as you can see the series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron, and lead. Okay, let me solve few examples, such as aluminium when it reacts with steam. See children, steam is nothing but H2O. Water or steam both have the same formula. When aluminium reacts with steam, that's nothing but water, it gives aluminium oxide and hydrogen gas is liberated. Similarly, when iron means Fe, when iron reacts with water, it gives ferric oxide. Again you can see here hydrogen gas is liberated. Now here we can see that when a metal reacts with steam or water, when metal reacts with, here we have two different concepts. As you can see, when metal reacts with water, here when metal reacts with steam, both have the same formula, but see the product. This is very important. Don't neglect this point. When metal, any metal, when it reacts with water, it gives metal, can you see this? It gives metal hydroxide. Okay, when metal reacts with steam, it gives metal oxide. Any doubts? When metal reacts with water, it gives metal hydroxide. And next, when metal reacts with steam, it gives metal oxide. Got it? Now, as you can see, this is one of the most important question. Please don't skip this part as this topic is very important. See here, whether you take sodium or potassium, when it reacts with water, it gives sodium hydroxide. Hydrogen gas is liberated along with the heat. Potassium reacts with H2O. Okay, it gives potassium hydroxide plus hydrogen gas is liberated along with the formation of heat. Now, one more reaction, calcium, when it reacts with water, it gives calcium hydroxide. Again, here also heat is liberated, I mean hydrogen gas is liberated along with the formation of heat. But here the question is, remember this, very important, sodium and potassium, okay, when they react with water it catches fire, but calcium does not catch with fire. Why? Give reason. Why calcium do not catch fire? As you can see, in all these three cases hydrogen gas is liberated along with the formation of heat, but still sodium and potassium catches fire, but calcium does not catch fire. Why? Remember, the answer is give reason question. Sodium and potassium catches fire because, okay, enormous amount of heat is liberated. Okay, the reaction is vigorous. But calcium do not catch fire because the heat liberated is not sufficient for hydrogen gas to catch fire. So this is very important, you should not forget this answer. Why calcium, even though it is liberating hydrogen gas, why it does not catch fire? Because sufficient amount of heat, okay, is not liberated, okay, so that the hydrogen gas does not catch fire. So you should not forget the difference between these two questions. Next, when aluminum reacts with steam, it gives aluminum oxide plus hydrogen gas is liberated. When iron reacts with steam, it gives ferric oxide, again hydrogen gas is liberated. Okay, here it's react with water, so hydroxide, here it metal hydroxide, here when metal reacts with steam it gives metal oxide. So this is the difference between metal hydroxide and metal oxide. Now see here, very important topic, Fe. What is Fe? Iron. When a metal, okay, let me say this is metal A plus, it means it reacts with copper sulfate, CuSO4. So it is a solution of a metal. When metal reacts with metal solution, it gives metal solution plus metal B. When iron reacts with copper sulfate, it gives iron sulfate plus copper. Is this clear? Now as you can see, when Fe reacts with copper sulfate, it has displaced copper. It means nothing but metal A, when it reacts with metal solution of B, it gives metal solution of A along with the formation of metal B. So this reaction usually we call it as displacement reaction. Okay, as we can see here also we can see the displacement reaction. Is this clear? So what is displacement reaction? As you can see, when metal A reacts with metal solution B, it gives metal solution A and metal B. Similarly, again we can see the examples. When zinc reacts with sulfuric acid H2SO4, it gives zinc sulfate and hydrogen gas is liberated. When lead reacts with copper sulfate, it gives lead chloride plus copper. Okay, formation of copper. So these are the different reactions. Remember, Fe displaced copper, zinc has displaced hydrogen, lead has displaced copper. So this is what the examples of displacement reaction.
Metal react with oxygen and forms metal oxide and liberates hydrogen gas. What is the second reaction we studied? Metal react with water and forms metal hydroxide and liberates hydrogen gas along with heat. What is the third reaction we studied? Metal react with steam and forms metal oxide. And what is the next reaction we studied? Metal A reacts with metal solution of B to give metal B, and metal solution of A. And another important topic we studied is amphoteric oxides. What are amphoteric oxides? Some metal oxides react with acid as well as base to form salt and water. So these are all the important topics you should know. Metal plus oxygen, metal oxide. Metal plus water, metal hydroxide. Metal plus steam, metal oxide. And hydrogen gas. Metal, this is another one, displacement reaction. Fe plus CuSO4 gives CuSO4 plus Fe. What are amphoteric oxides and examples? Amphoteric oxides example: ZnO, Al2O3, K2O, Na2O. Amphoteric oxides reacts with both acid as well as base to form. Next we'll go to reactivity series. Reactivity series. What do you mean by reactivity series? It's a series of element which is arranged in the decreasing order of reactivity. Reactivity series is a reactivity series. So what do you mean by reactivity series? It is a series of metals arranged. How it is arranged? Arranged in the increasing or decreasing? Decreasing order of reactivity. Okay, so I'll write one by one. You see, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, after lead, hydrogen, copper, mercury, silver, gold. Okay, this is the series of metals. How it is arranged? Decreasing order of their reactivity. See, you first one is potassium and sodium and calcium. What is their reactivity? They are most reactive elements. Which are the most reactive elements? Sodium, potassium, calcium, magnesium, aluminium, all these are most reactive. When you come the middle of the metals in the series, when you come to middle, the reactivity decreases, and finally if you go down, they will become least reactive. So which is the least reactive now? Mercury, silver. What do you mean by Hg? Mercury. What is Ag? Silver. What is Au? What is Cu? Copper. See, you can see here hydrogen. Correct? Below hydrogen, whichever is there, it is least reactive. Above hydrogen, they are most reactive. So you can see potassium K, sodium Na, calcium Ca, magnesium Mg, aluminium Al, Zn zinc, Fe iron, Pb is lead. These are all little bit reactive. Which is the most reactive means first three: potassium, sodium, calcium. Next, magnesium, aluminium, zinc also reactive but less compared to first three. Getting? So this is the reactivity series. So in this, they'll ask objective type question. They'll give four metals. For example, K, Na, Ca, Mg. How will you put arrow marks from more to less? Potassium is more reactive than sodium. Sodium is more reactive than calcium. Calcium is more reactive than magnesium. This is how you need to arrange in the decreasing order. If they ask you to write in increasing order, how will you write? First you should write magnesium, less reactive, then calcium. Calcium is less reactive than sodium. Sodium is less reactive than potassium. So like this, they may ask you to write increasing order or decreasing order of their reactivity. Understanding? So which is the most reactive here? Sodium, potassium, calcium. Which is the least reactive? Mercury, silver, gold. Getting? So first two you should remember potassium and sodium. They react with water and catch fire. They react with oxygen also. So what they'll do in order to store them? Yeah, in order to store them, they're always stored under kerosene. Because if it is kept outside, it will catch fire or it will react with oxygen and moisture. So that is why it is always stored under kerosene. So this is the reactivity series. This is also very important for exam. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead. So remember hydrogen. Below hydrogen is less reactive. The elements above hydrogen is more reactive. So reactivity series is very very important for exam. Okay. So next topic we'll move on to how metal reacts with non-metal. This is also important. Metal reacts with non-metals and forms what? Ionic compound. Very very important topic. How metal react with non-metal. What happens when metal and non-metal reacts? Metal and non-metal reacts to form salt. Salt, it is also called as ionic compound. Very very important. So ionic compound and its property is very very important. So for example, you take sodium and you take chlorine. Sodium and chlorine. Sodium is a metal, chlorine is a non-metal. Sodium and chloride reacts to form sodium chloride. Sodium chloride is now salt or it is a ionic compound. How it will react? How it will react? How it will form bond? It will form bond by sharing of electrons or what? Transfer of electrons. Very good. Transfers sodium transfers electron to chlorine and forms sodium chloride. That is why it is called ionic compound. Ionic compound is formed by transfer of electrons from metals to non-metals. So sodium is metal, chlorine is non-metal. So the electrons are transferred from sodium metal to non-metal and forms ionic compound. They'll ask what is ionic compound? What you will write? What is ionic compound? They'll ask what you will write? Ionic compounds. Ionic compounds are the compounds formed by transfer of electrons from metal to non-metal. Very very important. How ionic compounds are formed? How ionic compounds are formed? Ionic compounds are formed by transfer of electrons from metals to non-metals. What bond is formed between them? What bond is formed between them? Ionic bond. What bond is formed between them? Ionic bond. So, what is ionic bond? They'll ask. What you'll write? What is ionic bond? What is ionic bond? The bond formed by transfer of electrons from metals to non-metals. So they'll ask very important, what is ionic compound and what is ionic bond. Sodium has how many electrons? 11. In the K shell, 2. L shell, 8. M shell, 1. Coming to chlorine. Chlorine has how many electrons? Okay, now let us study formation of ionic compounds. Sodium atomic number is 11. In K shell it has two electrons, L8, M1. Chlorine atomic number is 17. K shell has 2 electrons, L has 8 electrons, M has 7 electrons. So sodium is having 1 extra electron. So chlorine is having 7 electron in the last shell. So what happens? 1 electron from sodium is donated to chlorine, and then it will form Na plus and Cl minus. So this is how sodium chloride is formed. So there is a transfer of electron from sodium to chlorine to form NaCl. So Na plus Cl minus combines to form NaCl. So this is how sodium chloride is formed. Next we'll see how magnesium chloride is formed. How magnesium chloride is formed. Magnesium atomic number is 12. Chlorine atomic number is 17. In K shell it has 2, L8, M2 electrons. In chlorine, K shell 2, L shell 8, M shell 7. So there is one deficient in the last shell. Here 2 excess in the last shell. So what happens? Magnesium has 2 extra electrons. It will be donated to 2 chlorines. So one electron is for one chlorine, another electron is for another chlorine. Another electron is for another chlorine, and it forms Mg2 plus and Cl minus, but there are 2 chlorine, you should write Cl minus 2. So this is how MgCl2 is formed. So magnesium chloride is also an ionic compound because there is transfer of electrons from metals to non-metals. Then we'll see how aluminium chloride is formed. Aluminium has 13 electrons in K shell 2, L shell 8, M shell 3. Chlorine has 17 electrons, K shell 2, L shell 8, M shell 7 electrons. So there are 3 extra electrons in aluminium. So these 3 electrons are donated to each chlorine, 3 chlorines, and it forms Al 3 plus and Cl minus thrice. So this is how AlCl3 aluminium chloride is formed. So this is also asked in exam. Formation of NaCl, formation of MgCl2, formation of AlCl3. So you should remember sodium has 1 extra electron, aluminium has 3 extra electron, and chlorine has 1 deficient. So there is a transfer of electrons from metal to non-metal. So this is how ionic compounds are formed. And then they'll ask you how sodium oxide is formed. Sodium oxide, we know sodium oxide formula is Na2O. So to 2 sodium you should write sodium has 1 electron, oxygen has 6 electrons in the last shell. So it receives 2 electrons from both the sodium and forms Na2O. This is how sodium oxide is formed. And then they'll ask you how magnesium oxide is formed. MgO. How magnesium oxide is formed. Magnesium oxide. Magnesium has 2 valence electron. Oxygen has 6 valence electrons. So 2 electrons from the magnesium is transferred to oxygen and it will form Mg2 plus and O2 minus, combines and forms MgO. This is how magnesium oxide is formed. And then another important topic is properties of ionic compounds. Properties of ionic compounds. Properties of ionic compounds. So ionic compounds are nothing but salt. So this is one other very important question for 4 marks. First you should write about physical nature. What is the physical nature of salt? Physical nature of salt. Salt is always solid and ionic compounds are solid. That means there is a strong force of attraction between metals and non-metals. Because of its strong force of attraction, it is solid. So there is a strong force of attraction between the metal and non-metal, and the bond formed is very strong. So it is solid in nature, but somewhat it is brittle. Because of its strong force of attraction, it is having high melting point and high boiling point. Sodium ionic compounds have high melting point. Ionic compounds are also having high boiling point. Why it is having high melting point and high boiling point? They'll ask. You have to tell there is a strong force of attraction between metal and non-metal in ionic compound. Hence it is having high melting point and high boiling point. And one more topic you should tell about solubility. So do ionic compounds are soluble in what? Ionic compounds are soluble in water. It is not soluble in organic compounds like petrol or kerosene, anything. It is not soluble in organic compounds. So these are all the important properties of ionic compound. The last point in this is it is a good conductor of electricity. Ionic compounds conducts electricity because ionic compounds, when you put it in water, it will split as Na plus and Cl minus. The movement of these ions conducts electricity. So these are all the properties of ionic compounds. Ionic compounds are solid. Ionic compounds have high melting point and high boiling point. Ionic compounds are soluble in water and not soluble in organic compounds. Ionic compounds are good conductor of electricity. And in this only they'll ask why it is having high melting point, why it is having high boiling point. You should write there is a strong force of attraction between the metal and non-metal. And why it is conducting electricity means because it splits into ions. When you put sodium chloride in water, it splits into ions. These ions starts moving. The movement of these ions are responsible for the conduction of electricity. Ionic compounds, why it will conduct electricity means you should tell they split into ions when diluted, and then it will conduct electricity. So in this topic only, they'll ask the diagram. Show how will you prove ionic compound conducts electricity. So for that you need to draw a diagram. Take a beaker, fill the beaker with ionic compound solution. So we should mix salt and water, and then we have to take it in a beaker. So for this beaker we should insert two graphite rods, and these graphite rods are connected to battery, switch and bulb. Okay, battery, switch and bulb. This is graphite rod. The solution taken inside is sodium chloride plus water, ionic compound plus water, and this is beaker, and graphite rods with wire, battery, bulb, switch. Okay, so these are all the apparatus required for showing ionic compound conducts electricity. So after battery you need to draw bulb, and then you need to draw switch. So inside this we should take the salt solution. So this is a diagram for ionic compound conduct electricity. Ionic compound conducts electricity. This is also important topic for 2 marks. Important topic for 2 marks. So graphite rods, battery, bulb, switch, beaker and salt solution. So these are all the properties of ionic compound, and ionic compound conducts electricity diagram. 4 marks properties, 2 marks this diagram. Very, very important. And why question also they'll ask. Why ionic compound conducts electricity? Why ionic compound conduct electricity? Because of ions. Then another important question, why ionic compound has high melting and boiling point? Why it has high melting and boiling point? Why it has high melting and boiling point? Because it has strong force of attraction between metal and non-metal. Okay, these are the two important questions. 2 marks or 1 mark. Why any compounds conduct electricity? Why any compound has high melting and boiling point? Another important question, how to extract the metals? Extraction. The extraction of metal from its ore is called metallurgy. Okay, extraction. So in extraction, the important topic is roasting and calcination. Every time in exam they'll ask for the difference between roasting and calcination. So what is roasting and what is calcination? Roasting means eating the sulfide ore. Roasting means eating the sulfide ore in the presence of oxygen. Eating sulfide ore in the presence of oxygen is called roasting. Calcination means eating carbonate ore. Eating carbonate ore in the absence of oxygen. Calcination is done in the absence of oxygen. So roasting sulfide ore, zinc sulfide, when you roast in the presence of oxygen, we get zinc oxide and sulfur dioxide. Calcination, you take carbonate, zinc carbonate ore and eat it in the absence of oxygen. It will also form zinc oxide plus carbon dioxide. Here you can see sulfur dioxide gas is released in the roasting, carbon dioxide gas is released in the calcination. So in the calcination, this also point you can write. In roasting, sulfur dioxide is released. In calcination, carbon dioxide is released. So here presence of oxygen is important. There you should write absence of oxygen. So roasting is done in the presence of oxygen. Calcination is done in the absence of oxygen. So whatever the zinc carbonate ore is obtained, zinc oxide is obtained, we should eat them again with the carbon. Here carbon is a reducing agent. It forms zinc plus carbon monoxide or carbon dioxide. Carbon monoxide. Here also zinc oxide we obtain. Zinc oxide should be reduced to zinc by using the carbon oxidizing agent. So zinc plus CO. So this is the difference between roasting and calcination. Roasting means eating the carbonate sulfide ore in the presence of oxygen. Calcination means eating the carbonate ore in the absence of oxygen. So here you can see oxygen, here there is no oxygen. What the main intention is to obtain the metal. The main intention is to obtain the metal from its ore. Here zinc sulfide is ore, we get zinc. Zinc carbonate is the ore, we get zinc. From the carbonate ore we get zinc. Here sulfide ore we get zinc. This is the difference between roasting and calcination. So another important topic they'll ask here is thermite reaction. Another important reaction, another important question from this lesson is thermite reaction. Thermite reaction means we should use the high reactive element, high reactive metal is used to, high reactive metal is used to reduce metal oxide to its metal. Okay, reducing metal oxides to metal by using one high reactive metal is called as thermite reaction. So I'll write the reaction, you will understand. For example, Fe2O3. Fe2O3. Fe2O3 is metal oxide. So this metal oxide can be reduced to metal. Fe2O3 is reduced to metal Fe by using aluminium. And aluminium reacts with oxygen and forms aluminium oxide. So here you should understand high reactive metal aluminium is used to reduce iron oxide to iron. So using high reactive aluminium, we can convert metal oxide to its metal is called as thermite reaction. Where this thermite reaction is useful? Thermite reaction is useful in joining the Thermite reaction is used to join the railway tracks and cracked machine parts. Thermite reaction is very important because it is used to join cracked machine parts. It is used to join cracked machine parts and also to join railway tracks. So thermite reaction means using some high reactive metal, we can convert metal oxide to metal. We can convert metal oxide to metal by using high reactive metals. So this is also, you can tell it is a displacement reaction. It is a displacement reaction. So thermite is very important. High reactive metal aluminium is used to reduce metal oxide Fe2O3 to Fe. This is called thermite reaction. So you can take MnO2 plus Al also. So another example I'll show you, MnO2. Another example, MnO2. MnO2 is manganese oxide. This can be reduced to manganese by using aluminium. Here also aluminium is more reactive element. When you use more reactive element, it will reduce metal oxide into metal. Metal oxide into metal and form Cal2O3. So you can see aluminium high reactive element. It displaces manganese from its metal oxide and it will give Mn. So this is also thermite reaction. 3MnO2 plus 4Al gives 3Mn plus 2Al2O3 and along with that heat is liberated. This reaction is used to join railway tracks and also for joining the cracked machine parts. So what you can tell, high reactive metal is used to reduce metal oxide to metal. This is called thermite reaction. This is, you can see here oxidation and reduction both in this reaction. So which is oxidized and which is reduced in the above reaction? MnO2 is reduced to Mn, aluminium is oxidized to Al2O3. So this you can tell it is an oxidation and reduction reaction, and that means it's a redox reaction. So MnO2 is reduced to Mn, Al is oxidized to Al2O3. Fe2O3 is reduced to Fe, Al is oxidized to Al2O3. So this is an example for redox reaction also. High reactive metal is used to reduce the metal oxide into metal. So this is called thermite reaction. Very important reaction for exam. So we'll go to next topic, electrolytic refining of copper. Electrolytic refining of copper. This also they'll ask in exam diagram how to refine the metals. So refining of metals by passing the current is called electrolytic refining. As the name itself tells, electrolytic. Electrolytic means passing of the current. Electrolytic refining of copper. So by passing the electricity, we can refine the metal. So that is called as electrolytic refining of copper. For this, we need to take a big tank, and inside the tank, 2 copper rods should be inside the tank. We should keep 2 copper rods. One copper rod is pure copper rod, another one is impure copper rod. So pure copper rod is made cathode, impure copper rod is made anode. So copper rod can be made cathode by connecting into positive terminal of the battery. Anode should be connected to negative terminal of the battery. Sorry, positive terminal anode, negative terminal cathode. So here anode is impure copper rod and cathode is pure copper rod, and inside this we need to take copper sulfate solution. Inside this we need to take copper sulfate solution, CuSO4. CuSO4, acidified copper sulfate solution. As we pass the current, the impure copper from the anode goes and deposits to the impure copper from the anode goes and deposits on the cathode. So this cathode is now pure copper rod, and whatever the impurities are there, they'll go and collects at the bottom of the tank, that is called as anode mud. This is how some metals like copper, zinc, tin, nickel, silver, every metals can be refined by passing the electricity. This is called electrolytic refining. This diagram they will ask for exam. Electrolytic refining of copper. So things you have to take is pure copper rod, impure copper rod, and just connect them to battery and plug key and pass the current. When we pass the current, pure coppers from the anode goes and deposits at the cathode, and impurities will be connected down at the bottom of the tank. So this method is used for refining of metals. And then we have topic in this lesson is corrosion. So what do you mean by corrosion? What do you mean by corrosion? Metal reacts with air, water, moisture, acids, and becomes rust. This process is called corrosion. How can we prevent corrosion? Corrosions can be prevented. They'll ask you prevention also. Prevented by alloying, greasing, oiling, galvanizing, and anodizing. So these are the methods of preventing corrosion. Corrosion can be prevented by these methods. Since we have alloying here, you have to know what is alloy. What do you mean by alloy? And then we'll study what alloy. So what is alloy? Alloy is a homogeneous mixture of metals and non-metals. It can be metals and metals can also be mixed, or metals and non-metals can also be mixed to form alloy. Here one word is given, homogeneous. What do you mean by homogeneous? Homogeneous means it should be completely mixed. Two metals and non-metals should be completely mixed. So such type of homogeneous mixtures of metals and non-metals are called as alloy. So for alloy we have so many examples. One is stainless steel. Stainless is a mixture of nickel, chromium and iron. These three metals are mixed homogeneously, then we get stainless steel. Next, another brass. Brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. Solder is an alloy of lead and tin. So where we will use this solder? In the welding of electrical wires. And one more important question they'll ask, why toaster? Bread toaster is made up of alloy, they'll ask, because it is having high melting point, it's a good conductor of heat, and also it do not corrode easily. Why toaster is made up of alloy? Because it has high melting point. It has high melting point. It do not corrode. It do not corrode easily, and it is a good conductor of heat. It is a good conductor of heat. Because of these three reasons, electric toaster is made up of alloy. So here brass and bronze will ask in exam. Brass is an alloy of dash and dash, copper and zinc. This time they have asked stainless steel is an alloy of dash, nickel, chromium and iron. If these three materials are mixed, then it will form stainless steel. Why we need to alloy? In order to prevent corrosion. So another method of preventing corrosion is anodizing and galvanizing. So we have seen alloying. Now another method of preventing corrosion is anodizing. What do you mean by anodizing? Coating a thick oxide layer. Coating a thick oxide layer on aluminium. So if aluminium is coated with thick oxide layer, and the aluminium will not get corroded once again. That is why on the aluminium a thick oxide layer is coated. This is called as anodizing. Anodizing is a method of preventing of corrosion. Another method of preventing corrosion is galvanizing. What do you mean by galvanizing? Iron or steel metal will be coated with zinc metal, because zinc will not corrode. Iron will get corrode, and steel also gets corrode, but zinc will not corrode. So when we coat zinc on iron and steel, that process is called galvanizing. Galvanizing is done in order to prevent corrosion. So there are so many methods. One is painting, second one oiling or greasing, third one alloying, fourth one anodizing, fifth one galvanizing. And also there are so many methods like electroplating. These are the methods of prevention of corrosion. Next is, what is mineral? What is mineral? Mineral is a naturally occurring element. So minerals we get naturally. Okay, the elements or compounds which occur naturally in the earth crust. So the minerals we get in earth crust. It's an element or a compound. It is a single element, or it may be in the form of compound, which will occur naturally in the earth crust, are called minerals. Then what is ore? Ore is nothing but it is a mineral from which we can extract a metal profitably. So from the mineral we can extract metal. For example, from the hematite ore we can extract iron. From the bauxite ore we can extract aluminium. From the magnetite we can extract iron. Cuprite we can extract copper. Copper glans is a ore. We can extract metal, copper metal. So like this, from the ore we can extract the metal profitably. We can extract the metal. See here I have taken reactivity series. Reactivity series is an orderly arrangement of elements in the decreasing order of their reactivity. More reactive metal is potassium, next sodium, next calcium, magnesium, aluminium, zinc, iron, lead, copper, silver, gold. So here in the decreasing order of their reactivity, it is arranged. The series is called reactivity series. So how can we extract the top elements in the activity series is by the process of electrolysis. So the middle elements in the reactivity series can be extracted by the process reducing by carbon, that is by calcination and roasting. And the metals which are present at the bottom of the reactivity series are found in native state. It's free, it is as it is available, so we need not have to extract. So then we need to study what is, which method I told for the top reactivity elements. I told electrolysis, right? Electrolysis means we should take its solution. For example, if we want to extract the sodium, we should take sodium chloride solution and pass the current by using graphite rods. These are all. What is this? This is a graphite rod, and this is also a graphite rod. Both should be connected to positive terminal of the battery and negative terminal of the battery and a switch. So when we pass the electric current, the sodium chloride solution, in the solution sodium chloride, so it will split as Na plus and Cl minus, and the sodium metal is required, right? The sodium metal goes and deposits on the negative plate, so that sodium can be profitably extracted from its solution. If we want to extract potassium, so potassium chloride solution should be taken in a beaker, and it should be supplied with electricity with a graphite rods. Once we pass the current, potassium chloride splits as K plus and Cl minus, and all the potassium ions goes and deposits on the negative plate. By this method of passing current and extracting the metal is called as electrolysis. By electrolysis, we can extract the I-reactive metals like sodium, potassium, calcium, magnesium, etc. So our next lesson is carbon and its compounds. The next chapter is carbon and its compounds. In this chapter, carbon and its compounds, we should study the property of carbon. We should study what is covalent bond, what is valency, what is isomerism, what is the valency of carbon, what do you mean by catenation, what is functional group, what is saturated hydrocarbon, unsaturated hydrocarbon, and we will study the structures of alkenes, alkenes and alkynes, and then we will study some chemical properties of carbon compounds, and we will study what are the properties of ethanol, what are the properties of ethanoic acids, and some more important topics we will study in this chapter. The most important one is isomerism, functional group, saturated, unsaturated, and the chemical properties of carbon compounds. And here we'll see what is carbon. So carbon is a non-metal. To which group it will belong? It will belong to 14th group, and the carbon atomic number is 6. Carbon mass number is 12. So how to write the electronic configuration? In K shell it has 2 electron. In K shell it has 2 electron. In L shell it has 4 electron. Since it has 4 electrons in the outermost shell, its valency is 4. Since it has 4 electrons in the outermost shell, its valency is 4. It can also be called as tetravalent. So carbon can form 4 bonds. Carbon can form 4 bonds because its valency is 4, and it shares 4 electrons and forms 4 covalent bond. It will neither accept electrons nor donate electrons. It only share electrons. How many electrons it will share? It will share 4 electrons. So we'll see how it will share and why it will not accept, why it will not donate. Okay, next topic is covalent bond. So what do you mean by covalent bond? What do you mean by covalent bond? Covalent bond means it's a bond formed between two atoms. It's a bond formed between two atoms. Okay, the bond formed between two atoms. How the bond will be formed? By sharing of electrons. So here you can see hydrogen. Hydrogen is having 1 electron in the outermost shell. Another hydrogen is also having 1 electron in the outermost shell. Each hydrogen will share 1 electron and it will form a single covalent bond. So how can you tell the sharing in oxygen between the two oxygen? Oxygen has totally 6 electrons in the outermost shell. Another oxygen also has 6 electrons in the outermost shell. So both oxygen will share 2 electrons. In order to obtain octet structure, it has 6 electrons. One oxygen will share 2 electrons. Other oxygen also shares 2 electrons, and it will form 2 covalent bonds. And after sharing, each oxygen should have 8 electrons in it. Okay, next, how we can see the bonding in nitrogen. Okay, next is bonding, covalent bonding in nitrogen. Nitrogen has 5 valence electrons in the outermost shell because its atomic number is 7. In K shell it has 2 electrons, in L shell it has 5 electrons. So since it has 5 electrons, it will share 3 electrons in order to obtain octet structure. So both the nitrogen will share 3 electrons and forms 3 covalent bonds. So this is how equally both the atoms will share equal number of electrons and covalent bond is formed. In hydrogen there is a single covalent bond. In oxygen there is 2 covalent bonds. In nitrogen there are 3 covalent bonds. So this is called covalent bond. Bond formed by sharing equal number of electrons between the two atoms. And there are 3 types of catenation: straight chain catenation, branched chain catenation, closed chain catenation. Straight chain means the carbon will link together with other carbon in a straight manner. Branched chain means carbon links in a straight chain and with one branch. Closed chain catenation means carbon can link itself with in a closed manner. This is called closed chain carbon catenation. And hydrogen, compounds containing carbon and hydrogen is called are called hydrocarbons. So from the name only you can understand hydrocarbons means it should have what and what? Hydrogen and carbon. If any compound has hydrogen and carbon, then it is hydrocarbon. See, for example, I'll take methane. Okay, methane. So what does methane contain? Methane contain carbon and hydrogen. If it is containing carbon and hydrogen, then it is called hydrocarbon. Understood? Hydrocarbon. Yes. In the hydrocarbon, there are 2 types. Which are they? Yes, in the hydrocarbon there are 2 types. One is saturated and another one is unsaturated hydrocarbon. Okay, so there are 2 types of hydrocarbon. Okay, there are how many types of hydrocarbon? There are 2 types of hydrocarbon. There are 2 types of hydrocarbon. What are the 2 types of hydrocarbon? Saturated hydrocarbon and unsaturated hydrocarbon. What do you mean by saturated hydrocarbon? Hydrocarbons having single bond between the 2 carbon atoms. Between the 2 carbon atoms, if there is a single bond, then it is called single covalent bond is there means it is saturated hydrocarbon. So what is unsaturated hydrocarbon? Okay, hydrocarbons having double bond or triple bond between the 2 carbon atoms in an hydrocarbon, then it is called unsaturated hydrocarbon. For saturated hydrocarbon, there is another one name, which is that alkane. And double bonded compounds are called alkene. Triple bonded alkyne. Got it? For alkane, we have general formula CnH2n plus 2. Alkene CnH2n. Alkyne CnH2n minus 2. So this is the difference between saturated and unsaturated. Saturated means single bonded hydrocarbons. Unsaturated means double or triple bonded hydrocarbons. This is also important topic for exam. Saturated, unsaturated. Example also you should give, formula structure you should write and name them. Alkenes are saturated, alkenes and alkynes are unsaturated. And they may also ask, alkanes are single bond, alkenes have double bond, alkynes have triple bond. And also they'll ask the formula. Alkane CnH2n. And then you should know how to write the structure of alkane, alkene and alkyne. Okay, so how to write alkane? Alkane first member. For alkane, in alkane first member is methane. Second member is ethane. Third member is propane. Fourth member is butane. Fifth member is pentane. Sixth member is hexane. Seventh member is heptane. Heptane, octane, nonane and so on. Okay, alkenes. Alkene first member is ethene. Alkyne first member is ethine. This is also important. Which is the first member of alkane? They'll ask. Which is the first member of alkane? Methane. Which is the first member of alkene? Which is the first member of alkyne? Got it? Okay, this is how they'll ask first members. First member of alkane, first member of alkene, first member of alkyne. Okay, so next, their formulas you should know. Alkane general formula CnH2n, CnH2n plus 2. CnH2n plus 2. Alkene CnH2n, alkyne CnH2n minus 2. Okay, this is how you need to remember formulas and first members. Got it? And then they'll ask the structure. You should know meth means meth. Meth means 1 carbon. Heth means 2 carbon. Prop means 3. But means 4. Pent means 5. Hex means 6. 7. Hept means 7. Got it? So like this you should remember meth, eth, prop, but, pent, hex, hept, oct, non and deca. We will try to write the structures of methane, ethane, propane. Okay, in exam they'll ask you to write the structure of how will you write the structure of ethane, they'll ask. Okay, eth means how many carbon? 2 carbon. Ane means single bond. Put all single bonds and write all H. Next, how to write the structure of ethene, they'll ask. Eth means how many carbon? Ene means double bond. Between the 2 carbon, write double bond. Rest you should write 2 bonds. So for 1 carbon, how many bonds should be there? 1, 2, 3, 4. For 1 carbon, there should be how many bonds? 4 bonds. And rest you write hydrogens. Hydrogen, hydrogen, hydrogen. How to write the structure of ethyne? Eth means 2 carbon. Yne means triple bond. Rest how many hydrogen I should write? 1. Next, how to write the structure of propane? Prop means 3. 1, 2, 3. Ane means what? Single. Write all single bonds. Remaining one all what you should write? Hydrogen you should write. Then how to write the structure of butene? How to write the structure of butene? But means how many carbon? 1, 2, 3, 4. Ene is there. What bond you should use? Double bond. Anywhere you can put double bond. Once you put one double bond, rest you put single. All single, and each carbon should have 4 bonds. Here 1, 2, 3 is there, put 1 more. Here already 2 is there, put only 2 bonds. And you should write H. This is how you need to write the structure of butene. Next, if they ask you to write the structure of pentyne, how will you write? Pent means 1, 2, 3, 4, 5 carbons. Yne is there. Triple bond. Anywhere in the carbon chain you can put 3 bonds, and rest you make 4 bonds. So 3 is there, put 1. 3 is there, put 1. Here 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So like this you should write the structure of pentyne. So Ene means double bond, Ane means single, Yne means triple. I hope you understood. So next I'll ask you then how to write the structure of uh, butane. How to write the structure of butane? Okay, butane. So how to write butane? But means how many carbon? 1, 2, 3, 4. An is there. What bond? Single. All single. All single. Each carbon should have 4. So this is how you need to write the structure of butane. And rest you should write hydrogen. Okay. Then if they ask you to write the structure of propene, how will you write propene? How will you write propene? Prop means how many carbon? 3. 1, 2, 3. En is there. Where you one place you should put double bond. Rest all single. For each carbon there should be 4. This is how you need to write the structure of propene. Ready? Okay. Next, how to write the structure of butane? Tell me how to write the structure of butane. You can use formula also, but this is also a simple and easy way to write. But means what? But means 4. 1, 2, 3, 4. Since you have Y and E, what you should write? Triple bonds at one place. And make it 4. 1, 2, 3, 4. Already 1, 2, 3 is there. Make one more bond 4. Here for this carbon 4. 1, 2, 3, 4. For the last carbon also 1, 2, 3, 4. And you should write H. Okay, this is how you, so structure is very important. Structure of methane, structure of alkane, alkyne they last, so you should practice this. Okay, this is all about structure of alkane, alkene and alkynes. So like this, they'll ask the structures of alkanes, alkenes and alkynes. They'll give the name, you need to write the structure. ANE single bond, ENE double bond, YNE triple bond. Meth, eth, prop, but, pent, hept, X. You should remember the number of carbons. So next you came to know what is unsaturated and saturated hydrocarbons. So the next very important topic for exam is isomerism. Very important. Isomerism or isomers. Isomerism means what? Two compounds. See, two compounds, for example, butane. Okay, two compounds. Butane. So here I have written two structure. One is I have written two structure. One is butane. Here also you have 4 carbon straight structure. Here also you have 4 carbon but branched structure. So both are butane. Both are having 4 carbons but the structure is different. So this is called normal butane. 4 carbon in a straight structure is normal butane. 4 carbon in a branched structure is called as isobutane. So you can see two compounds having same formula C4H10 but different structure. Such property is called isomerism and such compounds are called as isomers. So what is isomerism? Two compounds or two hydrocarbons having same molecular formula but different structural formula or different structure are called isomers. But this property of isomers are called Isomerism. This property is called isomerism. Got it? So here you can see both are having C4H10. This is also C4H10. But the thing is, this is straight chain. This one is branched chain. Okay, two compounds having same molecular formula C4H10, C4H10, but the different structure, straight chain and branched chain. This is called isomer and isomerism. So they'll ask, pentane has how many isomers? So butane has how many isomers here? Two isomers. Butane has how many isomers? Two isomers. So one is normal butane, another one is isobutane. So like that, pentane has how many isomers? They'll ask. This is the first isomer. Butane is the first isomer. So the next one is pentane. So pentane has how many isomers? They'll ask. Pentane means 5 carbon. As we know, pent means 5. So you can write pentane in the straight manner like this, or else you can write the pentane in the branched manner, or else you can write the pentane in the two branches, one up one and other one is down. So like this you can write three structure for pentane. So you can tell pentane is having three isomers. One is straight chain, one is branched chain, and another one is branch upside and downside. So if it is straight chain, then it is called normal pentane. If it is straight chain, then it is called normal pentane. If it is having branch one side, then it is called isopentane. If it is having branch both the sides, then it is called as neopentane. So like this, pentane is having three isomers. One is straight chain, one is branched, and the other one is branch both up and down. So like this you can write the isomers for pentane. How many isomers? Three isomers. Which are there? Which are there? N-pentane, N-pentane, isopentane and neopentane. So like this, three isomers you can draw for pentane. If you go to next to hexane, how many isomers you can write? Hexane. See, for butane 2, for pentane 3, for next member 4, next member 5, like that. Got it? So usually they'll ask pentane. Pentane, how many isomers you can draw? How many isomers you can draw for pentane? 3. For hexane, 4. For heptane, 5. For butane, 2. Which is the first isomer? Butane. How many isomers you can draw for butane? 2. So this is all about isomers, isomerism, and number of isomers you can draw for a Okay. So next topic is functional group. Very important again. Functional group. So what is functional group? It is a single atom, or it can be group of atoms. It's a single atom or a group of atoms. So for example, I'll tell you, you'll understand. What it will do? It will decide the properties of carbon compounds. It will decide the properties of carbon compounds to which it is attached. So it's a group. Functional group means it may be a single atom. Or it may be group of atoms. What is functional group? It is a single atom or group of atoms. What this group of atoms or single atom will do? It will decide. What it will decide? It will decide the property of carbon compounds. For example, I will list all the functional groups, then I will explain. Okay, so which are the functional groups? So halides are the functional groups. Tell me which are the functional groups. First one, halides. Which are the halides? Chlorine, bromine, iodine, etc. Okay, these are the functional groups. Second one, alcohol. Alcohol functional group is, alcohol is a functional group. It's OH is the OH. It is alcohol is having two atoms. One is O and one is H. Alcohol is OH. Aldehyde. 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 CHO. Aldehyde is a CHO. Carboxylic acid. Carboxylic acid. Carboxylic acid is COOH. Ketone. Ketone. C double bond O. So amine. Amine NH2. So these are the functional groups. See, you can see it's single atom or also group of atoms. Which are the single atoms here? Which are the single atoms here? Chlorine is single, bromine is single, iodine is single. Group of atoms. OH is double, CHO, COOH, C double bond O, NH2. So you can tell, and functional groups are nothing but it is a single atom. It is a single atom, or it may be group of atoms, which will decides the properties of hydrocarbons to which it is attached. Got it? Okay. So if hydrocarbon, if an hydrocarbon is having OH as a functional group, how you should name? How you should name? OL. If it is having CHO group, how you should name? AL. If it is having COH group, how you should name? OIC acid. If it is having C double bond O, you should name it as ONE. If it is having NH2 functional group, you should name it as amine. If you have Cl in that, you should name it as chloro. If you have iodine in that, you should name it as iodo. If you have bromine in that, you should name it as bromo. So this is how you should name. Naming is nothing but nomenclature. If it is having OH, you name with all OL. For example, 3 carbon is there, 1 OH is there. How will you name this one? 3 carbon, propane. 3 carbon, propane. At last OH is there. What will you name? OL. 3 carbon, at last OH is there means you should name it as propanol. 4 carbon is there. At last there is CHO. How will you name this? Name the 1, 2, 3, 4, 5. 5 carbon is there means pentane. At the last there is CHO. You should name it as AL. So like this, OH is there means you should name it as OL. So you should know naming, and also you should know structure, how to write the structure. So let us study how to write the structure with the functional groups. Okay, so one by one, listen. So first they'll ask you to write pentane all. Otherwise they may ask you to write pentaneal. If they'll ask you to write pentanoic, they'll ask you to write pentane amine. Pentane amine. So you should see OL is there. You should see AL. You should see oic acid is there. You should see at the last there is amine. So whenever there is OL, you should use OH. Whenever there is AL, you should use CHO. Whenever there is oic acid, you should use COOH. Whenever there is amine, you should use NH2. So let us write the structure. So here pent means how many carbon? 1, 2, 3, 4, 5 carbon, and at the end you should write what functional group? OH functional group. So like this you can write the structure of pentanol, pentanol, OL is there means you should write OH. Next coming to pentanol, coming to pentanol. So here pent means 5, but already with functional group 1C is there, so you write only 4 carbon. Okay, in the CHO there is 1 carbon, so you should include that also, and this is how you can write the structure of pentanol. This is how you can write the structure of pentanol. Then pentanoic acid. In pentanoic also in COOH 1 carbon is already there. So including that you should write 5 carbons. Write 5 carbons like this, and at the end there should be COOH. This is how you can write the structure of pentanoic acid. They ask you to write pentanamine. Pent means 5 carbon and amine means NH2. Like this you should write the pentanamine structure. So one more they'll ask you to write pentanone, O-N-E. O-N-E is there means you should use the functional group C double bond O. You should use the functional group C double bond O. So how to write the 5 in that C double bond O there is 1 carbon. So you should include that also and write 5 carbons with C double bond O, and then write remaining all hydrogen. So like this you should write the structures and name them and using the functional groups. In pentanone also there is 1 carbon C double bond O, that should be also included while writing the carbon chain. This is how you need to write the structure of including functional group. So next topic is homologous series. Next topic is homologous series. Homologous series. Let us see what is homologous series. First I'll take the examples. First member of alkane is methane. Next member of alkane is ethane. Third member is propane. Fourth member is butane. Fifth member is pentane. Sixth member of alkane is hexane. So like this, in this family of members, okay, in this family, first one is having the formula CH4. Second one is having the formula C2H6. Third one is having the formula C3H8. Fourth one is having the formula C4H10. Fifth one is having C5H10. Sixth one is having C6H14. So when you take the difference between these two, when you take the difference between first member and the second member, if you take the difference, what you will get the difference? You will get the difference of CH2. C2 minus C1 is C. H6 minus H4 is 2. So if you take the second member, if you take the third member and fourth member, if you take the third member and fourth member also, you will get the same difference CH2. See this two member I'll take. So in this two member, if you take the difference, how will you take the difference? C4 minus C3 is C. C10 minus 8 is 2. So now you can call this series as homologous series. Why this series is called homologous series? Because they are all having the same general formula alkane, but they are differing each other. They are differing each other by what group? CH2 group. Such family of members which differ each other by CH2 group, such family of member which differ each other by CH2 group are called homologous series. So you can give example for homologous series means you can tell alkane family, alkene family, and also you can tell alkyne family. In this family, first member and second member, third member, fourth member, every members, successive members will differ each other by CH2 group. If you take alkyne also, first member, second member, third member, fourth member, fifth member, successive member will differ each other by what group? Successive member will differ each other by CH2 group. Hence these three family are called homologous series. So first member, second member difference will be CH2, second and third difference CH2, third and fourth difference CH2, fourth and fifth difference CH2, fifth member and sixth member, any member you take, successive member you should take. It will differ by CH2 group. Hence these groups are called homologous series. So give example for homologous series means what you will tell? Alkanes. Alkanes. Then give example for homologous series means alkane family, alkene family, alkyne family. All these are called homologous because one member and the next member differ each other by CH2 group. Or else they will ask why methane and propane are homologous. They'll ask. What you'll write? Why methane and propane or why methane and ethane are called homologous. What you'll write? What you'll write? Why they are homologous means what you'll write? Methane is CH4, ethane is C2H6. What they differ each other? Yeah, they differ each other by CH2 group. Hence both are called homologous. Got it? I hope you understood what is homologous. Okay, this is all about homologous series. Now I'll ask you one question. I'll give the structure. Whether it is homologous or not, you should tell. Okay, CH3OH. Another member is C2H4OH. Both of these are homologous or not? Okay, C2H5OH. Both methanol and ethanol homologous or not? They are homologous. Say the C2 minus C, H5 minus H3, H2. So they are differing each other by CH2 group. Then these two are homologous. Got it? Okay, next you take propanol. Propanol is C3H7OH. So you can see first one and second one and third one. See the second one and third one. C3 minus C2 is how much? C. H7 minus H5 is how much? H2. They are differing each other by CH2 group. Then what it is called? Yeah. If you take butanol, next member. Butanol is C4H9OH. Propanol and butanol homologous. Propanol and butanol is homologous. Yes, they are homologous. C4 minus C3. C. H9 minus H7. H2. All are differing by CH2 group. Take two members, subtract them. If they differ by CH2, then it is homologous series. Very important question for okay, and they'll also ask in the exam number of bonds, number of covalent bonds in the structure. They'll give one structure. For example, you take they will give the structure of like this C3 and then one OH. Okay, rest of them all are H. How many covalent bonds are there? They'll ask. So you count the bonds. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are how many covalent bonds? 10 covalent bonds. Name the structure. 3 carbon means prop. 3 carbon means prop. P-R-O-P you should write. Whenever you have OH, you should write OL. Whenever OH, you should write OL. Propane, all. 3 carbon propane. Whenever there is OH, you should write OL. Propane, all. So like this, you need to name. Now one more structure I'll give. You should name it. Okay. See 1, 2, 3, and one CHO group is there. The rest all are hydrogen. Okay. How to name this compound? Okay. See, one carbon is there. One carbon, one carbon, two carbon, three carbon, four carbon. What is the name? Butane. Okay. CHO is there. Al. CHO is there means it's an aldehyde. You need to write Al. In that group, C is there, no? That also you should count. Got it? This is how you need to name the compound. So 1, 2, 3, 4 but. CHO is there means Al. It's a butanol. AlCHO. OLOH. Okay. So now I'll give you one more structure. You name them. C double bond O and C. Okay. So count the carbon. One carbon, two carbon, three carbon. Three carbon means what is the name? Propane. When you have C double bond O, what you should name? ONE. This is propanone. And remember, one carbon should have only one bond. Here 1, 2, 3, 4. Carbon should have 4 bonds. So middle carbon 1, 2, 3, 4. This last carbon 1, 2, 3, 4. So one carbon should have 4 bonds because its valency is 4. Got it? Okay. So now I'll give the name. You need to write the structure. Pentane amine. How to write the structure of pentane amine? Pentane amine. How to write the structure of pentane amine? Pentane amine. Pent means how many? 1, 2, 3, 4, 5. Amine means what group? NH2 group. For each carbon, how many bonds? 4 bonds. Rest of the things, what you should write? Hydrogens. This is the structure of pentanamine. Okay. Next, another important topic is benzene. How to write the structure of benzene? How to write the structure of benzene? What is the formula of benzene? Very good. Benzene is having the formula C6H6. This is also another topic for important question. Benzene formula C6H6. How to write the structure? Write 6 carbon in a cyclic manner. Write 6 carbon in a cyclic manner with alternate single and double bond. Right? Single bond, double bond, single bond, double bond, single bond, double bond. And all carbon should have 4 bonds. So like this you should write the 4 bonds and rest you should write hydrogen. So this is the structure of benzene. How many carbons in benzene? 6. How many hydrogen in benzene? 6. So like this you need to write the structure of benzene. You can write like this or else you can write the cyclic ring like this and put one circle like this. So this is also the structure of benzene. So what is benzene? It is an aromatic hydrocarbon. So what do you mean by aromatic? Aromatic means sweet smelling hydrocarbon. Aroma means smell. Okay, sweet smelling hydrocarbon, benzene. Benzene is having the formula C6. Carbon in a cyclic manner with alternate, single, double bond. Benzenes are used in the manufacture of perfumes. It is used in the manufacture of dyes. It is also used in the manufacture of medicines, etc. So another important structure they may ask you is toluene. Toluene is also aromatic hydrocarbon. In this, you should write a benzene ring with one CH3 group. So this is called as toluene. You can write like this, or you can write 6 carbons, alternate single bond, double bond with one CH3. With one CH3. So this is the structure of toluene. Benzene ring with one CH3. Or else you can write in another way also. Or else you can write in another way also. Okay. Six carbons like this. Alternate single and double bonds with one CH3. Remaining all H. Remaining all H. This is the structure of toluene. Toluene is also used for dyes, medicines, etc. TNT, trinitrotoluene explosives. Explosives are nothing but bombs. Okay, TNT, trinitrotoluene explosives. Okay, so then they may ask you the structure of salicylic acid. Salicylic acid also 6 carbons, alternate double and single bond, alternate double and single bond with COOH group. So this is the structure of salicylic acid. Another structure is naphthalene. Naphthalene is insect repellent. So this naphthalene consists of three benzene rings. Naphthalene consists of 2 benzene rings attached each other. So this is the structure of naphthalene. This is the structure of naphthalene. Naphthalene is an insect repellent. It will be white color. You might have kept in cupboards, and it's a sweet smelling compound. Moth repellent. Moth repellent. Salicylic acid is also used for preparation of medicines. So this is all about the aromatic hydrocarbons. One is benzene, another one is toluene, another one is salicylic acid, another one is naphthalene. All these are aromatic hydrocarbons, sweet smelling compounds. They are used in medicines, drugs, dyes, and explosives, etc. Then we should study cycloalkanes. Cycloalkanes. Cycloalkanes means carbon which are bonded each other in a cyclic manner. This is cyclopropane. Carbon bonded hydrocarbons having three carbons in a cyclic manner. This is cyclopropane. So cycloalkane always starts by prop, because by 3 carbon only we can make a cyclic ring. Another one is cyclobutane. So this is the 4 carbon bonded in a cyclic manner. This is called as cyclobutane. Another one is cyclopentane. So like this, so 5 carbon, 6 carbon, it will be go on bonding each other. This is called as cyclopentane. So this usually cycloalkenes will have the general formula as that of alkene, CnH2n. This is the general formula of alkane, cycloalkanes. General formula of cycloalkane is CnH2n. They ask you to write cyclopentane or cyclohexane. X means how much? 6. C6H2 into 6. What you'll get? C6H12. If they ask you to write cyclobutane, but means how many? 4. C4H2 into 4. Or what you'll get? C4H8. So using the formula, You deduce the structure, you deduce the formula and then write the structure. So this is cyclopropane, cyclobutane, cyclopentane. Next comes cyclohexane. Are they homologous? Are they homologous? Do they differ each other by CH2? Okay, cyclopropane means C3H6. Cyclobutane means C4H12. So they are not homologous. Carbon, one carbon is differing, but hydrogen there is no difference of two. Hence they are not homologous. Okay, this is the structure of cycloalkanes. What is the difference between cycloalkanes and benzenes? Cycloalkanes are saturated, all single bonds. Benzene is double bond, it is an unsaturated. That is the difference between cycloalkanes and benzene. And cycloalkanes are aliphatic. Benzenes are aromatic. Okay, getting? Aliphatic means single bonds. Okay, you should write the difference between cycloalkanes and benzene. What is the cycloalkane and benzene difference? They'll ask in the exam. What you'll write? These are all having. See, next we will see covalent bonding in methane. Covalent bonding in methane. Okay, methane. What is the formula of methane? Methane is CH4. Methane is CH4. So here you can see at the center I have written carbon. How many electrons carbon shares? 4 electrons. Why? Because its valency is 4. At the outermost shell of the carbon there are 4 electrons. These 4 electrons are shared with 4 hydrogen. 4 hydrogen. Okay, so each carbon and hydrogen shares one electron, mutually shares one electron and forms 4 covalent bond. 4 covalent bond. So this is the structure of electron dot structure of methane. CH4. So this is another important question. Why carbon cannot gain electrons, or why carbon only shares electrons? Why it cannot gain? Why carbon cannot gain? Why carbon cannot gain or lose electrons? Lose electrons. It can only share. It can only share. Why not it can gain, or why not it can lose electrons? Why it will not gain? Because there are totally 6 protons. If it accepts 4 electrons, if it accepts 4 electrons, if it accepts 4 electrons, then the 6 protons cannot hold 10 electrons. It already has 6 electrons in it. If it accepts 6 electrons, if it accepts 4 electrons, the 6 protons present cannot hold the extra 4 electrons. So 6 protons cannot hold 10 electrons. Why it cannot gain means you should write. It is difficult for the 6 protons to hold 10 electrons. This point you should write. Why it does not gain 4 electron? Because it is difficult for 6 protons to hold 10 electrons. This point. Why carbon cannot gain 4 electrons? Because it is difficult for the 6 protons to hold 10 electrons. And then why it cannot lose 4 electrons? Why it cannot lose 4 electrons means for losing 4 electrons more energy is required. For losing 4 electrons more energy is required. So that is why the carbon cannot lose 4 electrons. The carbon needs a large amount of energy. Carbon needs large amount of energy to gain to lose electrons. That is why it will not lose electrons. Why carbon cannot lose 4 electrons? Because losing 4 electrons, it needs a large amount of energy, so it will not lose electrons. So you cannot write carbon plus 4 or carbon minus 4. So it always shares 4 electrons. It neither gains nor accepts. So next topic is catenation. What do you mean by catenation? Carbon is having a special property to go to link with other carbon atoms to form a very long chain. This special property of carbon to form a long chain is called as catenation. See, you can see carbon, carbon, carbon. It goes on linking with other carbon atoms and forms a long chain. So this is a special property. Carbon, 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 carbon. Like this, so many carbon atoms can link together to form a long chain. This unique property or the special property of carbon is called as catenation. Next, we will go on to chemical properties of carbon compounds. Next, we will go to the topic chemical properties of carbon compounds. Chemical properties of carbon compounds. So, first property is combustion. First property is combustion. So, what do you mean by combustion? Combustion means burning. So, when we burn the carbon compounds in the presence of oxygen, so burning in oxygen, what happens? Let us see. So carbon compounds I'm telling no. So we should take carbon. What happens when we burn the carbon in oxygen? It will form carbon dioxide. What happens when we burn the methane? What happens when we burn the methane? What happens when we burn the methane? When we burn the methane, it will form carbon dioxide, water, and also it will release some energy in the form of heat and light. What happens when we burn the alcohol? When we burn the alcohol in the alcohol also it will release what? Water, carbon dioxide, heat and light. Okay, remember combustion. What do you mean by combustion? Combustion means burning. What we need to burn? Burn what compounds? Carbon compounds. What carbon compounds I have taken here? Carbon, methane, alcohol. So these three are carbon compounds because it is having carbon in it. So when you take the carbon compounds and burn and heat them in the presence of oxygen. So when you burn the carbon compounds in the presence of oxygen, it will give carbon dioxide, heat, light. Carbon dioxide, heat, light. Understood combustion? What do you mean by combustion? Combustion means burning. Burning of carbon compounds in the presence of burning means burning itself it is supplied with oxygen. Burning itself means it is supplied with oxygen. So when you burn carbon in oxygen, it will form carbon dioxide. When you burn methane in oxygen, it will form carbon dioxide, heat and light. So second reaction where you can see you can see in the kitchen daily when we go to kitchen, you switch on the gas. The gas is released is methane. What you are lighting is oxygen. So when you burn the methane gas with oxygen, you can see some gas will be evolved. That is carbon dioxide. You can see some heat and light also evolved. Because of this heat and heat only we can cook the food. Getting? So this is the combustion. So you take alcohol. Alcohol when you burn, then also it release some gas, release some oxygen, it release some light. You can see this some people, circus people, they'll put alcohol on their hands and then fire them. They can show some heat and light like a magic. They'll do this. Correct? So this is a combustion. Getting what is combustion? Combustion means burning the carbon compounds. Burning the carbon compounds in oxygen. Getting? So this is about combustion. So this is the first property, chemical property of carbon. Okay. Here you should remember methane. Methane is a constituent of which gas? LPG gas. LPG gas consists of methane. Okay. Second property will go to move to oxidation. What do you mean by oxidation? Oxidation means addition of since we are studying carbon compounds, addition of oxygen to carbon compounds. Addition of oxygen to carbon compounds is called, in this chapter it is, we are dealing with carbon compounds. So what happens when we add oxygen to carbon compounds, we will see. Okay, adding oxygen to carbon compounds. Okay, you take alcohol, C2H5OH. What happens when we add oxygen to alcohol in the presence of potassium permanganate? What it will give? CH3COOH. What is this called? Ethanoic acid. What is C2H5OH? Ethanol. So how can you convert ethanol to ethanoic acid? They'll ask. How can you convert ethanol to ethanoic acid? By heating. By heating alcohol in the presence of potassium permanganate or potassium dichromate. Okay, so ethanol can be converted to ethanoic acid by heating in the presence of oxidizing agents like potassium dichromate or potassium permanganate. Okay, so this is called what reaction? Oxidation. Why it is called oxidation? Because here see, in ethanol only one oxygen is there, one more oxygen is added, correct? In here 6 hydrogens are there, here only 4 hydrogens are there. How many hydrogens removed? 2 hydrogens removed. How many oxygen is added? So what is oxidation then? Addition of oxygen or removal of hydrogen is called oxidation reaction. Like this also they can ask, or how to convert ethanol to ethanoic acid. How to convert ethanol to ethanoic acid? By heating ethanol in the presence of oxygen and oxidizing agents like potassium dichromate and potassium permanganate. So this is an oxidizing agent because it adds oxygen. Because it adds oxygen, it is an oxidizing agent. Next reaction is addition reaction. Next reaction is what? Addition reaction. What do you mean by addition reaction? Converting unsaturated hydrocarbons. Converting unsaturated hydrocarbons into, very good, converting unsaturated hydrocarbons into saturated hydrocarbons in the presence of nickel as a catalyst. Okay, addition means you need to add hydrogen. So you can convert unsaturated hydrocarbons into saturated hydrocarbon in the presence of nickel or palladium as a catalyst. This is called as what reaction? Addition reaction. And this is also called as what type of reaction? Hydrogenation reaction. Hydrogenation reaction means converting unsaturated hydrocarbons into saturated hydrocarbons. What is the function of nickel? What is the nickel? Why it is used here? It will speed up the reaction. Nickel is a catalyst. It is used to speed up the reaction, but it do not involve in the reaction. So anytime in catalyst do not involve in the reaction, it just speed up the reaction. Okay, it increases the rate of reaction. What is the function of catalyst? It increases the rate of the reaction, but do not involve in the reaction. So this is called addition reaction. Getting? Okay. Okay, next we will go to some important carbon another reaction is substitution reaction. Another reaction is substitution reaction. Substitution reaction, for example, methane is there. How can you substitute hydrogen, one hydrogen? By using what you can substitute one hydrogen? By using chlorine. So chlorine is nothing but here halogen. By using the halogen, we can substitute the hydrogens. This is called as substitution reaction. So using the halogens, we can substitute the hydrogens present in the hydrocarbons. This is called as substitution reaction. Then we will have ethanol properties, uses, and ethanoic acid property and uses. So we will see what it is. Last topic. Okay. What is the ethanol? What is ethanol? Ethanol formula C2H5OH. What is the property of ethanol? What is the property of methanol? Ethanol, it is colorless liquid. Where it is soluble? It is soluble in water. And what happens when you add water to ethanol? 5%. Okay, it is soluble in water. So this is all the physical property. So next we will see chemical property of ethanol. What happens when ethanol react with sodium? Ethanol reacts with sodium and forms sodium ethoxide. Sodium ethoxide. And what it will release? It will release hydrogen gas. What happens when you add some sulfuric acid to ethanol? What happens when you add sulfuric acid to ethanol? It will convert into ethene. This is a good dehydrating agent. Which one? Concentrated H2SO4 is a good dehydrating agent. What it will do? It will remove the water from the ethanol. Okay. So these are all the two chemical properties. When you add sodium to ethanol, sodium ethoxide, when you add concentrated H2SO4 to ethanol, it will form ethene by removing the water. So H2SO4 is a concentrated, H2SO4 is a good dehydrating agent. Then what is the use of ethanol? It is used for making alcohol drinks, and it is used as a solvent, and also it is used for making tincture cough syrups. Okay, these are the uses of ethanol. So ethanol formula is important, ethanol chemical reactions are important, ethanol uses are important. Uses, it is used in some alcoholic drinks, it is used as a solvents to dissolve something, it is used as an tincture or cough syrups, etc. Next we will go to ethanoic acid, last topic of this lesson. Okay, so then we'll go to ethanoic acid. Ethanoic acid. What is the formula of ethanoic acid? What is the formula of ethanoic acid? CH3COOH is the ethanoic acid. It is also a colorless liquid. It is also soluble in water. If we mix 5% of water to it, it will become vinegar. Okay, vinegar it will become. These are all the properties of ethanoic acid. Then uses of then its chemical properties. Chemical properties of ethanoic acid. Chemical properties of ethanoic acid is, when you take ethanoic acid and if you mix with alcohol, it will form a sweet smelling compound, ester and water. This is called as esterification reaction. Esterification reaction means ethanoic acid reacts with alcohol and forms ester. Ester is having the functional group COOH. Then it will form CH3COONA, sodium ethoxide, plus water. When you take ethanoic acid and add some washing soda to it, it will form sodium ethoxide plus water plus carbon dioxide. When you take acetic acid and add some baking soda to it, it will form sodium ethoxide and it will liberate water and carbon dioxide gas. So these are all the four chemical properties of ethanoic acid. One is with alcohol, it forms ester. One with base, it forms sodium ethoxide. One with washing soda, it will form sodium ethoxide salt. When with baking soda, it will form sodium ethoxide salt plus water plus carbon dioxide gas. These are all the chemical properties of ethanoic acid. And one more is there, saponification. So what is saponification? So when you take ester, C2 CH C2H5 COOCH3, when you add sodium hydroxide to an ester, it will form sodium ethoxide plus alcohol. This can be used for preparation of soap. Hence it is called as saponification. So the next, and the next topic is soaps and detergents. Soaps and detergents. In the exam, they'll ask you the difference between soap and detergent. Okay, soap and detergent. Soap is sodium salt of sodium salts of long chain carboxylic acid. Detergents are sodium salts of long chain sulfonic acids. The difference you should know. So long chain fatty acids are soap, long chain sulfonic acids are detergents. Soap cleans well in hard water. So soap do not clean well in hard water. Detergent cleans well in hard water. Soaps is not as good as detergent, but detergents are better. Always detergents are better cleaning agent. Soap is not having better cleaning agent. Soap is biodegradable. Do not cause pollution. But detergents are non biodegradable. It will not decompose by microorganism. So since it is not non-biodegradable, it will always cause pollution. So this is the difference between soaps and detergents. So it's a carboxylic acid, here it is a sulfonic acid. No, we will know the structure of soap molecule. Okay, soap molecule is having a long chain fatty acids with a one end is having ionic part, the other one is having hydrocarbon part. So this is an hydrocarbon chain and this is an ionic part. This is ionic part and this part is water repelling part. This is water repelling part. This is water attracting part. This is water attracting part. When the soap is dissolved in water, it will form a spherical structure. It will form a spherical structure. The spherical structure formed by soap when it is dissolved in water is called as micelle. So how it itself forms a spherical structure in such a way that the ionic part will be outside and the part will be attracted towards the dirt. So in the middle there is a dirt. So water repelling part, that is hydrocarbon part, is attracted towards the dirt and the ionic part is always outside. The spherical structure of soap molecule so formed when it is dissolved in water is called as micelle. So when this then structure is formed, when you wash this, when it is, and then the dirt will be removed. So this is the cleansing action of the soap. So in each micelle, soap molecules are arranged radially such that hydrocarbon is towards the center and ionic part is always outside the center, and it will form an emulsion, and then it can be washed thoroughly with water and removed. So this is all about cleansing action of soap. So I hope you understood all the three lessons: acid, bases and salts, metals and non-metals, and hydrocarbon. If you once you go through this video, you'll understand and you can clear all the questions and answer in the